All right, let's get started. So again, today we are solving systems of equations, and the solution is that point of intersection. Doesn't matter the method, our end goal is still the same. First, we're going to review the first two methods that we learned, graphing and substitution. So we learned graphing and substitution. So graphing, I would do graphing when I have one or both equations that are written as y equals form. And what is that form? Slope intercept. I would use substitution when you have one equation that's written as x or y equals. So whenever you have x or y equals, I would use substitution. Elimination. Elimination is useful when you have equations that are written in standard form. And combining them would cancel or eliminate one of the variables. So eliminate. And another word for eliminate is cancel. So you're going to eliminate or cancel, and eliminate is up here. This is our new method that we are learning today. Elimination. First, I would like to go over slope intercept and standard form. Slope intercept, you should already be good with that form. What's it look like? Yes, y equals mx plus b. That's really good for graphing. It's good for graphing, and m stands for what? Slope. And what is b? Y-intercept. Slope-intercept form. So slope-intercept is really good if you want to graph. Standard form. Nobody likes standard form, but it's actually pretty powerful, and it's nice if you want to use elimination. So standard form looks like this. AX plus BY equals C. So this is when you have the system and it's set up in columns where you've got your X part, your Y part equals some constant or some number. And so if you look at example number 1, you'll see that they're set up like that. You've got X's, and then you have Y's, and then you have a number at the end. Does everybody see that on example 1, how they're set up in this form? It's on your paper. Don't look at the board. Look on your paper. Do you see how example 1 is set up like that? Okay, a few of you are playing along. Maybe the rest of you are still waking up on a Friday. The elimination method is sometimes called the addition-subtraction method, because ultimately that's what we're doing. We have two equations and we're going to add or subtract them together. And with elimination method, you get rid of or cancel or eliminate one of the variables by adding or subtracting. So eliminate, I'm going to write cancel, bless you, get rid of, all the same thing. So we are adding or subtracting the equations to cancel, get rid of, eliminate one of the variables. And this is going to be kind of the opposite of substitution. When we did substitution, the first substitution involved a little bit more math. We had to distribute combined like terms, and then we had a two-step equation. And then the second time we substituted, it was really easy. In fact, some of y'all were doing it in your head. I wanted to see the work, but some of y'all were doing it in your head. With elimination, the first step is really fast and easy, and the second step is a little bit longer. So it's kind of in reverse. It's kind of the same amount of work, but it's in reverse. So the steps for using the elimination method, we're going to make sure that the equations are in standard form. The variables must line up. I'm going to go ahead and write that form down again so that we're very familiar with it. It's AX plus BY equals C. They've got to be in rows like that. So columns. We're going to combine the equations by adding or subtracting, and we combine the X part, the Y part, and the constant part all separately. And when you do that, you should eliminate one of the variables, and then you'll continue by solving. And then we're going to use substitution to solve for the other variable. So this is like elimination substitution. And some students really like this method, and some students really don't like this method. You might like it, you might not. It's okay. I have to expose you to it. So our first example, and there's kind of a guide over to the right. Are the equations in standard form? Will combining them eliminate one variable? Are these in standard form? Yes. Would combining them cancel a variable? Which variable would cancel? The Y, because 2 minus 2 is 0. Yeah, the Y. So yes, we can continue. 2 minus 2 is 0, so my Y is going to cancel. I'm going to mark it off. What is the number in front of X if there's no number? 1. So I get 4 plus 1 is 5x equals, what's 12 minus 2? 10. All right. Do I have x equals? I have 5x equals. Could I easily make x equals? So that's what it says here. Do I have x or y equals? No. Could we solve for it? Yes. So what would I do to solve for x? Divide by 5. And yes, I think I heard it. 10 divided by 5 is 2. That's one part of my equation. I like to see that you solve for both parts. And my solution is always going to be x comma y. Parentheses matter. If you do not put them, I take points off for every problem that you don't put your solution in parentheses. I know the x part of my solution is 2. And now I need to solve for y. It does not matter what equation that you decide to plug your 2 into to solve for y. So we've got the top equation and the bottom equation. Which equation do you want to plug into? The bottom, and here's the reason why. Both of these variables have a number attached to them, a coefficient other than 1. And this one only has a 1. So this one to me looks a little simpler. So I'm going to plug into the bottom one since I didn't have an overwhelming majority for the top equation. So let's do part 2. Part 2, we're going to substitute. So this is my second step. I'm going to rewrite that second equation, and I'm going to leave myself a space where the x is. And I'm going to plug in for x. I'm going to plug in 2. Now that I know that x is 2, I'm going to plug it in. At this step, I have a 2-step equation. To get y by it for itself, I'm going to first bring over the 2 and subtract 2. Negative 4. And then what's my last step? Yep, I need to divide by 2. So y is equal to negative 4 divided by 2. What is that? Negative 2. So I just solved for the second part of my solution. My solution is x comma y. And you need to show me that you solved for both variables. Some of you did some weird math and you solved for one, but you didn't show me that you solved for the other. You get half credit for that problem. So please make sure that you show me that you solved for both. I don't know. I feel like this might be a little bit less writing than substitution. But some people really prefer it. You might as well after you do a couple problems. Just depends. Let's do some more examples. So let's try some more onto the back of your notes. We've got a couple more examples. So for example 2, do I have a variable that would cancel? Which one? Y, because negative y plus y is 0. So I have a variable that's going to cancel. And what's the number in front of the x if there isn't one? 1. So when I combine them, 1 plus 2 makes 3x equals 19 plus 11, 30. And then one last step to get x by itself. Yep. Divide by 3. So x is equal to 30 divided by 3 is what? 10. You can always use a calculator. I'm not checking to see if you know your multiplication tables or you can add and subtract with negatives. I'm checking to see if you can use the elimination method. So use a calculator if you struggle with those things. Now that I know x, I know part of my solution. My solution is x comma y, or that point of intersection. And so I know that the x part is 10. And now I need to go find y. Which equation do you want to plug into, the top or the bottom? Why should we plug into the top one? Yeah, there's less variables attached to the, less coefficients attached to the variables that are other than 1. So I agree, the top equation's a little easier, just a little less numbers. So I'm going to plug into the top one. It's not wrong if you plug into the bottom one. You can plug it into either one. I'm going to leave myself a space for the x. Minus y equals 11. So for the x, I'm going to plug in what x is. X is 10, so I'm substituting. I'm plugging in 10. And it's usually the same step when you start solving. I'm going to bring this to the other side. It's positive over here, so when I bring it over, I'm going to subtract. Don't lose the negative on the y. What's 11 minus 10? 1. And what's the number here? I don't see a number, but there is a number there. What is it? It's a 1. So I need to get rid of the negative 1, and it's the same step that we always do. I need to divide by negative 1. What's 1 divided by negative 1? Negative 1. So I have solved for both of my variables. And I am good to go. Nathaniel, I need you to rein it in. Just through the notes. Just through the notes. I found my point of intersection. I'm good to go. Done. The next problem, do I have a variable that will cancel? Which one? Yeah, the variable x will cancel if I combine those. So minus 6 plus 6, that will cancel. So I eliminated the x variable. Now I'm going to add these, combine these equations. 5 and 4 make 9. What's 1 minus 10? Negative 9. What's my next step to get y by itself? Yep, divide by 9. Yep, negative 9 divided by 9. Anything divided by itself is 1. A negative divided by a positive is a negative, so I get negative 1. I have half of my answer. My answer is x comma y, or that point of intersection. And so I don't know the x term, but I know y is negative 1. Which equation should I plug this into to solve for x? Okay, why the second one? Because what? You don't have to multiply y as much because this is a smaller number. That's fine. Also, I kind of like the second one because this has a negative and this one doesn't. I like that too. It doesn't matter. Just pick an equation and plug it in. So this is my second step. I have 6x plus 4. I'm going to leave myself a space for the y equals negative 10. So I rewrote the second equation and I leave myself a space for the y. Y is negative 1. So I'm going to go plug that in, negative 1. This one has a little bit more steps to it. So I need to evaluate this. What is 4 times negative 1? Negative 4. So I have 6x minus 4 equals negative 10. This is a two-step equation. What should I do? Yeah, let's get the 4 to the other side by adding. Negative 10 plus 4 is negative 6. Very good. What's my last step? Let's divide by 6. Negative 6 divided by 6 is what? Negative 1. Beautiful. Negative 1. The solution to a system is the point of intersection. That is the point of intersection. Let's play some Family Feud. Name a zoo animal that eats more than you do.
Hey,
We did that. Awesome. Next round for double points. Name the occupation of someone who could cut you.
Doctor. Oh. That's part of the barber. Is it true? Shit. I don't think that's smart.
What'd you say?
Coach.
Who uses like knives or sharp things?
Butcher. That's a cat. Hey,
Good job. We're off to a great start. Round 3, triple points. Name an animal that doesn't have a leg to stand on.
Yeah. Seahorse, sea cucumber. No, they have a whale. Whale. No fish.
Any underwater things
Does it have a leg to stand?
needs to stand.
Shut up.
Things without legs. Animals without
Joe. Joe Constant.
What's that kind of snake?
Wait, what whale? Yeah.
I put whale.
That one, and it said already yes.
Also, please remember that even though we take a brain break, that doesn't give anybody permission to be on their phone. So I shouldn't see phones and I shouldn't see you on your phone. So to protect yourself, put your phone in your backpack so you don't get it again. Like I said, I wrote a referral last class, this same class. So don't make me do it again. Name something a hiker would have in his backpack.
Water.
Hiking water. Name something big that you might buy to protect yourself with. Something big.
That's
A dog would be good too. Name a type of cheese Americans like the best. Or cheddar. If you need some fast cash, name a possession you might sell. Name something in the house teens use for hours at a time. I bet it will say computer. I don't think gun is big. I guess I was thinking bigger.
Yeah.
perfect.
All right, it's that time. I'm gonna give you some homework time.
In your house, dog. In your house.
So right now, actually, as we have homework time, the question that I want you to start with is actually question 11. Go to question 11, because question 11 is just a review of solving by graphing. So you have two equations, graph them, and find the point of intersection. It's an easy question, but I feel like when everybody leaves it for last, they think, oh, it's a word problem. I can't do this. You can do it. Do that problem first, and then flip over and start with question 1. So do the last question first, and then go back. And you have 10 minutes for homework time, so please make good use of it. No, you have 10 minutes for homework time. Like right now. And then we're gonna finish notes. 11.
Okay, it was 10:35.
Cause no face.
Yeah, no ways.
In the life again. I hate being the.
I just start pulling the friggin' metal screw.
No, like 60 people.
Oh, yeah. Shut up. You that and who that we have.
I haven't gathered.
It's not. One of the things is looking at insulated lines.
Very close, but yeah. Very, very close, but it's not. It's positive. It's all the same.
Yeah, it sounds good. Yeah, all the same. It's all the same. It's they're both the same. It's like.
Anthony, I missed you last class. Did you get the stuff?
Oh, yeah. I think that's what we have.
Yeah, when we're done with the notes.
I'm seeing. Yeah. You're smart in your own. Yeah. This one, so. One of the ones that I remember you keep saying, some of the chicken. Think about it. Is it a topic? Yes, I do.
You'll do that every single week.
Oh, I'm looking. Yeah, there's some- Please. Five years ago.
Okay.
How many times? How many times? What? How many times? Yeah, divide by two. Oh, that was it. Yeah, hey, I'm gonna get negative one. Okay. Wow. I'm just freaking. Well, I don't need it. I'm subtracting that. Right. This is. I keep getting water. So that's just fine. It could be worse. How do you get that? Oh, God. Believe me, it's all home.
You still have 3 minutes. Please make sure you're working on your homework. Some of you are doing some awesome work and some of you are just sitting there.
Oh, no, it's bad. He's one from Frank. No, I don't think it's spinning from. I don't backwash it, like break it down. He's so hungry. It's a section. It's my phone, bro. Bro, where's that coming? My phone. What happened? What happened?
You can turn it off.
I don't know what happened. It's no, I was that dog. I was on the what register. You felt like bro. No, it wasn't. It was. What? You not know the camera on it? Yeah, I think so. On this, bro. No. They made the symbol for 7, 9 this. And then this is nice. My favorite is not just every single time. No, it's just it isn't one. No, they made it like real quick. It's 6, 7. He can do it. So many. Which one? 6, 7. No, spend 5, 3, 2, 9. I don't know if I can show it. I don't know if I can show you. I It's it'll go 86753 for some reason. Yeah, if you look at here, the files, they're on the base. Yes. I was joking because that's much for them. Why would these negative? You can't end on a negative variable. That's wild. When I thought negative variable, I'm not negative. Why? And or negative one. Wow. Everybody would divide, but whatever the number. Why for the other? No, I just heard you want one. It's the number of 130. What number do you spend that one? To make the y a positive. Why is this doing? What's 7
All right, we are ready to continue with the notes. So let's switch back to the notes so that we can finish.
Yeah.
So at the bottom of your notes, or sorry, midway down your notes, it says just because your equations are in standard form doesn't mean that you're ready to eliminate. I don't think it's oftentimes. I think it's more like sometimes. Because most of the questions on your homework, you don't have to do this. So sometimes you have to make a small adjustment first. So answering the same questions, this is just a guide. Are the equations in standard form? Yes. I've got a column of x's, a column of y's, a column of constants. Will combining them eliminate a variable? Will combining these eliminate a variable? No, nothing cancels. So here's the deal. We can make an adjustment to one of the equations so that they would cancel. And I usually try and look at my more simple equation. I would say that this one is more simple because I have one coefficient that's a 1. So that's really easy to work with. And so if I wanted this to cancel with a -4, what would this need to be? A +4. So what if we took, and anything you do to the equation, you have to do to the whole equation. What if I multiplied the whole equation by 4? And I would have to multiply every single piece by 4. So I'm going to do that, but I'm also going to just rewrite the first equation. I'm not doing anything with it, but I have to still combine these. So I'm just going to rewrite it as it is. And now I'm going to distribute in a 4 to the second equation. So 4 times 1 is 4. And it's positive. 4 times -3 is -12. And then what's 4 times -6? -24. All right. Now, if I was to combine these, would a variable cancel? Which one? The x's will cancel. So now I keep on keeping on. So after you combined, we're going to combine. So 9 minus 12, what is that? -3. What's 9 minus 24? -15. And I just have one step to get the y by itself. Yep. Divide by -3. A negative divided by a negative will be a positive, and 15 divided by 3 is 5. So I know the first part of my solution. Bless you. After combining, we didn't have x equals, but we solved for it really simply. Now we have x or y equals. So in this case, we have y equals. Our solution is always going to be x comma y. I know the y part of my solution is 5. Now I need to solve for the x part. So I'm going to use substitution to solve for the other variable. Which equation do you want to plug into? Which one looks easier? Which equation looks easier, this top one or the bottom one? Yeah, I agree with the bottom one. The bottom one looks a little bit easier. The numbers are a little bit smaller and we have a variable, or sorry, a coefficient of 1. So let's plug into the bottom equation and I'm going to leave myself a space where the y is. And I'm going to use the original equation, not the one we multiplied by 4. So I have x minus 3 times y equals negative 6. So I rewrote this equation and I leave myself a space for the y. I'm going to substitute for the y. I'm going to substitute 5 and I'm going to put it in that blank. Well, now I need to get rid of those parentheses. Negative 3 times 5 is negative 15. And I have just one step to get the x by itself. What do I need to do? Yep, I need to get rid of minus 15 by adding 15. What's 15 minus 6? 9. So I know the second part of my coordinate. The solution to a system is the point of intersection. So the point of intersection is 9, 5. Do you think special cases could happen when you're eliminating variables? Do you think all the variables could cancel? I mean, they did when we did substitution. So yeah, the same thing can happen when you have elimination, that all the variables cancel and you're either left with a true or a false math statement. And we've been learning how to answer those questions. So what I'd like for you to do now is to go and work question 5 and question 6 from the homework. These, I'm telling you, they're special situations. And as you figure them out, go back to your notes and write down what happens. And make sure that you tell me that anytime you answer a solution as either no solution, that you tell me why. Why would we get no solution? What kind of lines? Parallel. No solution goes with parallel. What if you got infinitely many solutions? Why? Same line. Okay, you better put me reasons why. We are done. It's 10:24. You have 35 minutes. So yeah, you have enough time to get your homework done. You don't want homework over the weekend.